Do you think that we could take a RISC-V processor, break an instruction, and it would still run some firmware? Let's find out. Here we've got the RISC-V spec. I'm just going to wobble the mouse around randomly until I pick one. Okay, let's go with LHU. LHU loads a 16-bit value from memory. So, will that break the firmware? Let's change the address range so that it's wrong. And now I run make, which runs a simple test file, and it still works. Now I'll run make check, which starts the RISC-V formal process. I've sped up the footage to save time in this video, but when I run make check with 8 cores, it finishes in less than 30 seconds on my PC. And we can see that the formal verification picked up that problem. Let's try another one. Okay, let's go with an XOR. So I'll edit the firmware again, and we'll change this XOR to a plus. Let's see if the firmware still works. Okay, and now let's check with the RISC-V formal. Here's our very simple firmware. And the RISC-V formal finds it again. One more quick check. Let's go with BLT, and I'll just change this RS2 value to RS1. Firmware still works. And now the formal. Picks it up again. RISC-V formal is an open source verification library that works with the Yosis HQ formal tools. It's a processor-independent formal description of the RISC-V ISA. It's a set of formal test benches for each processor supported by the framework. The specification for the RISC-V formal interface must be implemented in your processor. Let's take a look at NERV, the naive educational RISC-V processor that Yosis HQ has put together to showcase the RISC-V formal tools. It fits in a single Verilog file, it's less than 500 lines long, and it demonstrates how to implement the RISC-V formal interface. To add the RISC-V formal verification interface, you can follow this guide. To get started with NERV and test this out for yourself, you can follow these instructions. We've even included an SoC example that runs on the 1-bit squared Icebreaker FPGA board. If your RISC-V processor is written in Verilog, then you can use the open source version of our formal verification tools. If you're using VHDL or System Verilog, then get in touch to ask for an evaluation license of the TabbyCAD suite. Thanks for watching.